So in the last class, we had some of the introduction about, general layer 2, layer 3 packet flow and all. So today we are going to start the switching part, right? So what we'll start with, if you'll check the content, the blueprint, there you'll find the switch administration part. So from there itself, we are starting. So as I told you that I'll be covering things from basic and I have added. So have I shown these? From where we have started. I guess this is what we have done, right? Okay, the initial part. Okay, it was done. We'll be starting the VLAN technologies today. Okay, not that part. That is already covered. Okay, then if you remember from your earlier studies, VLAN is basically, the what you can say, grouping of devices based on the domains or the departments, you can say, or it can be the grouping of, collection of devices on basis of the traffic type they are part of, right? So for example, let's say if you have sales, HR, marketing, different type of organizations and department in your organizations, then you can make a different VLAN for each. In the same way, let's say you have IP phones, you have cameras, you have internet, different servers and all that. You can make different VLANs. So basically what VLAN is doing for us, it is reducing the size of broadcast domain. In the collision and broadcast domain section, in the last class, if you remember, we have discussed that what will happen if the size of broadcast domain is larger, right? So your broadcast traffic, for example, the ARP traffic will flow in the entire domain, and end devices, they unnecessarily need to process that, and they are going to ultimately drop that traffic. So what we want, the size of broadcast domain should be the what you can say, shortest, the lowest, whatever you call that, right, as possible. So for that, Cisco has given us this VLAN, Virtual Local Area Network technology. Any question if you want to ask me about the basic idea of VLAN, or is that clear to everybody? Like benefits, why VLAN, all those basic questions. So this is, the primary reason behind the, VLANs, to split your physical broadcast domain into single physical broadcast domain into multiple logical smaller domains, right? So you can have, better control of your traffic and all. If you remember your three-layer architecture, Cisco's architecture, right, for designing the campus and enterprise networks, there, if you see, we have different, access, distribution, and core layer switches. And there, what we say, okay, switch to switch links are uplinks, the trunk links to pass all your different VLANs, and the ports or interfaces going towards your end devices, they are your access switches, right? So okay, your trunk links are specifically configured for the same purpose, that if you have multiple broadcast domains, so typically one device, or sorry, one interface can carry the traffic of only one VLAN. But for that, if you want, different VLANs, so if you remember something like this, maybe you have, done in your earlier studies, that if you have switch 1 here, right? And if you have switch 2 here, and this device is in VLAN 10, this interface is in VLAN 10, right? Okay, not 10 actually, before that. Let me say this is in VLAN 1, this is in VLAN 1, okay? And they will communicate with each other, right? Because by default, all the interfaces are in which VLAN? VLAN 1, right? So from here, we can also say there are different type of VLANs. One of them is your default VLAN, okay? So each interface by default is, in the default VLAN. But what about if this interface or this device is in VLAN 10, then it will not be communicating, right? So what we need to do, there are two solutions, right? You can say put this interface into VLAN 10 and they will communicate. But the problem with that approach is, if you have different devices in different VLAN, then you need a different interface in different VLAN. And if there are, let's say, 5 or 10 VLANs, you want to, communicate with each other. So I'm not talking about VLAN 10 to 20 communication, right? I'm saying 20 to 20 communication and 10 to 10 communication. For that, we are needing the dedicated interface. So just to, say, okay, I don't want this solution, what we can say that simply use, okay, not this, simply use a single link in here, okay, not multiple link, and make that link work as a trunk link. So this is all that we already know, just kind of revision thing, right? So from here we have concept of switch port types. So there are basically three type of ports. One is your access port, one is your trunk port, and third we have based on dynamic trunking protocol. So that is DTP working for us in Cisco domain. Dynamically, it can make your ports trunk because remember, trunking or let's say encapsulation. Okay. So encapsulation means adding the data identification. Okay. The frame, let's say it is coming from which VLAN. Okay. And when it is being received by the neighbor, it should be able to identify, okay, from which VLAN it is coming. So for that, we need to put some kind of tag on the frame. So for that, we need the encapsulation or the tagging protocol. So basically we have ISL and dot. So all these things we have already, I guess, studied, right? So we'll kind of, do all whatever are the missing things about these from your earlier studies. Let me show you then. Step by. So this is all, we'll continue this discussion in this way, and further then we'll say, okay, trunk links. Then you'll talk about the pruning of trunk links, allowed VLAN on trunk links, native VLAN, CDP, and all these things will, keep talking. Okay, VLAN number or the VLAN ID. Any question on how to disable it? Can I disable the highlighting? Okay, leave it for now. So one we have default VLAN and then we have normal VLANs, then we have extended. And any idea about where we use extended VLANs? Yes, anybody? If you want to, let's say, contribute. Okay. When we'll talk about, the routed ports in layer 3 switches. So what they does, they pass the layer 3 traffic, right? And they are capable of routing. You can configure IP addresses on them. So basically switches are what? Layer 2 devices, right? They work on the concept of broadcast domains. So what happens when you are making a layer 2 switch, layer 2 port as a layer 3? So then how switches make that happen? So that is based on the concept of this extended VLANs. So that's where we use it. And in VTP, we can configure the extended VLANs in VTP mode, if you remember that transparent. So there are, certain things that we are going to talk about. Okay, creating VLANs and how to. I'm asking once again, just for clarity, if anybody is there who need clarification of these basic things, how to create VLANs and how to name VLAN. If you want, I can, do some basic lab on this. If it is clear, then it's okay. Then you have, VLAN verification. Then basically it is a three-step process. You'll create a VLAN and for better documentation, it's good you will name the VLAN and finally you'll say, okay, which interface of the switch or which range of interface of switch should be accessing which VLAN or should be the part of which VLAN, right? And then if you'll talk about the administration of the VLAN database, so unlike your routers, that database is not stored in your NVRAM, it is stored in the flash memory, right? So if you want to delete a single VLAN, simply you can say no VLAN. And if you want to delete the entire database, then you can delete your VLAN.dat file in the flash memory. Okay, so there is this simple, it happens many a times. This is very simple thing, but you'll find that people do this mistake all the time. That if you'll delete certain VLAN, right? So, and the let's say interface is part of that VLAN. So deleting a VLAN. So what I'm trying to say is this: on a switch, if you will say, okay, FA 0 by 3 interface, the device connected to it is part of VLAN 22. And there in your VLAN database, this VLAN was there, right? VLAN 22. And if you deleted that VLAN, what do you think? You're thinking, okay, this will become the part of default VLAN? No, it will be the part of your VLAN 22. So manually you need to change it to the VLAN that you want it to be the part of. So that's one thing we need to remember. What else? Then we have the tagging protocols and the switch port types. So either a port can be access or a port can be trunk. Okay. And a single VLAN, if you need to carry, then towards your end devices, those are your access ports. Uplinks are majorly you'll find they are trunk. Okay, so trunk are, let's say, capable of adding the tags, right? So for trunking or the tagging, we use two protocol, right? ISL and dot 1Q. So ISL was Cisco proprietary, right? And dot 1Q is IEEE standard, you can say, or the industry standard or open standard. Any idea about what was wrong with ISL or what was the problem with ISL that even Cisco uses dot 1Q? Yes. Okay. So ISL has this limitation of adding the 30 byte of header. It kind of take your, let's say, entire data, entire frame, and on that frame, it puts the header and trailer. So 26 byte, it will add the header, and 4 byte, it will add the FCS. So it is kind of doing the encapsulation. So basically, in case of ISL, we say encapsulation, encapsulating the entire frame. But in case of dot one Q, it is tagging. So this is, kind of we use it interchangeably, encapsulation and tagging, but in actual exact sense, tagging is your dot one Q. Why? Because it takes your frame, okay, and it doesn't make any changes. It only add a 4 byte header in between, 4 byte tag in between just to identify, okay, this coming frame is belonging to which VLAN, right? So that's what your dot one Q is doing. And there is one more problem with the ISL. So one is bandwidth utilization, more bandwidth it need, and CPU you can say. Second is your support of native VLAN. There was no support of native VLAN in your ISL protocol. In here we have support for native VLAN, right? So how to configure your interfaces? That is, kind of straightforward. On the interface, you'll just need to define either it is the access port or it is the trunk port. And even in Cisco, you don't need to define the access, right? So when you'll want to make an interface, the part of some VLAN, you will say switch port access VLAN and that VLAN, right? So by default, the ports are in access mode. Why is that? So if you'll see, let's say this is your switch, and on this, let's say FA or kick 0 by 3, you are connecting some device, okay? And you'll say switch port access VLAN 20, right? So what will happen? It is working in what? So one mode is access, one mode is trunk, and one mode is dynamic. So by default, what is happening? DTP is working in your Cisco environment. So what it is saying that the port is dynamic access. Okay, you are not manually making it access. When you are not saying it trunk, so it is in what actually dynamic auto. So when it is dynamic auto, there is no device in front which is kind of initiating the trunk. So what it will be in access mode. So I'll show you. Okay, let me show you that just for clarification. There are certain things that we need to know about. Should I take I will, I guess, right? I'll need two. Okay, so if you'll check show interface status, then we have four interface in here, right? And what else? If you'll check show VLAN brief, then by default we have the default VLAN and we have the legacy or reserved VLANs, right? What else? Then all the interfaces are part of your default VLAN. Okay, and if you'll go on show interfaces Ethernet 0 by 0 and switch port, right? So here you can check details about the interface. First of all, you can see that this is your layer 2 enabled interface, right? And there are these two modes, admin mode and the operational mode. So admin mode is basically how it is kind of configured right now. And operational mode is how it is acting as, for example, right? So by default, as I talked about, both side interfaces, they are dynamic auto. So this interface is dynamic auto and this interface is dynamic auto also. So what happens when both sides are dynamic auto? The admin mode is what your DA. So operational mode will be what your access. So if both side are what is that dynamic auto, then the link will be access. Okay. So what is the necessary condition for becoming this link as a trunk? So either you say one side the admin mode is trunk, okay, not dynamic auto, but either a trunk where you'll say switch port mode trunk, okay, manually, or you'll say it is dynamic desirable, right? Dynamic desirable. So this is dynamic auto, that is dynamic desirable, DD, what we call that. So one side, if you are changing, the other side will automatically come on to the same terms with because why? It will say that I'm negotiating my parameters with you. So if all the parameters on this link, let's say here and here, what speed, duplex, native wheel, and all these things, if they match, then they'll become okay. The port, let's say this is, for example, dynamic desirable. This is dynamic auto. So links are there, sorry, interfaces are this, but the link will be trunk. So that's the idea about here writing the administrative mode and the operational mode. So one more example if I'll take here. So let's say if one side is your access, okay? I'm saying switch port mode access. So I'm disabling DTP here, okay? I'm not using DTP. And here I'm also disabling by saying, kind of disabling that this is my trunk, switch port mode trunk. So what will happen? This link will be working or not? Any idea? Anybody? What kind of link this will be? Up and running or down or what?
It will be done.
Down, right? So the provision is either one side should only be configured, right? Or if you are configuring both sides, then they should be in such a way that they give the working link. So make it happen like that, right? Okay. What else then? So the thing I wanted to clarify is about this admin mode and the operational mode. So if anybody is not having clarity on that, what else do we have in this output here? Then if you'll check, trunking encapsulation is a negotiate. Okay. Now, what does it mean? Negotiate means what? That this interface, let's say if this is your such a switch which support ISL, okay? ISL. I'll see that is it happening or not, but in theory they say if both support ISL, then the negotiated protocol will be which? Your ISL, right? Okay, but as I have seen the negotiated, okay, we'll see that in lab. We'll not comment anything without doing things. But the point is this DTP is used for what? Let's say you are using it for trunking. So for trunking, we have two protocols, ISL and dot one q. So DTP is used to dynamically, let's say select which trunking protocol to use. And by the way, it is just to study, just because it is there for some platform, but you will not find anybody using ISL. Just make the habit of production in, that you'll find, or you need to configure it in the dot one q mode. Okay, so and one more thing in the production scenario, just for a real world experience, if you're going to have that DTP is good for studying and the exam and all, but you will not find many people using DTP for the trunk formation. Okay, so manual is kind of preferred, way to do things in case of this trunking realm. Okay, then what next? We have the native VLAN. Okay. What is native VLAN? So,
I have one question.
yeah,
Uh,
yes, yes.
the administrative mode, dynamic auto is a default mode.
Most of the time. In different platform, it varies. Somewhere you can find dynamic desirable also.
Okay. So this is actually the configuration for the DTP,
Yes. Yes.
dynamic auto. Switch
Actually,
port mode that is disabling. And once we manually configure the trunking, we are disabling either the access port or we are making the trunk port. We are disabling the DTP, right?
no, switchport mode trunk doesn't disable DTP. For that, you need to say no negotiate.
No negotiate. Okay.
Yes. So this is kind of tricky with Cisco. Saying switch port mode access, yes, it will disable DTP.
Mm-hmm.
But in here, it will not disable DTP. If you'll, capture the packets, you'll find that packets are still kept, forward by DTP. But if you'll say no negotiate, then the capture, packets will stop of DTP and only your static will be there, right?
Okay.
Right. Then this, when you will say no negotiate, this will be off there. See, this negotiation of trunking. What else? Native VLAN tagging. Okay. Voice VLAN. Before that, let's talk, one by one. This native VLAN. So when we are saying that there are different devices in different VLANs, so they are sending their frames with tags, right? So that the receiver switch can identify that this particular frame belong to which VLAN. Okay, but in STP we will study that we not only use Cisco switches everywhere. Let's say there is this such domain that we are using this Cisco switch and it is connected with some non-Cisco switch. Okay. So Cisco switch has this different working of STP. It work on per VLAN. But let's say on non-Cisco, it doesn't work on, it simply work on CST, common spanning tree. We'll talk about that later. So how they are going to interoperate? So in this way, they are not going to talk to each other. And it means simply you cannot use non-Cisco switch with a Cisco switch, which is, kind of disastrous, right? So what happens? Why my meeting will end in 10 minutes? What is happening? Isn't it renewed? Okay, just let's focus on this topic for now. So what happens that for this interoperability, they, what I was talking about, native VLAN, yeah. So one of the VLANs should be such like it has no tag, okay, so that the non-Cisco switch can be on the same page for at least one VLAN, which is sending the control traffic. Remember control plane, that's TP traffic on the BPDUs and all. So this was the original region. Maybe you have heard about, okay, that there is a hub in the picture and hub doesn't understand frames, tagged frames. For that, we are using native VLAN. So yes, that can be one more valid reason. And basically, on any VLAN, if you want no tag to be present, then you make that VLAN as a native VLAN. Is that clear? The concept of native VLAN. We'll talk about native VLAN, at many different places. But yes. Okay, then what about voice VLAN? Yes, voice VLAN. If you remember, if you have seen, let's say if there is a switch, and with that switch you are using, let's say, let's talk about there is this, desk of let's say CEO, some manager or some normal employee, right? There is this laptop or PC, and they are having also this IP phone. So there is this wall jack, the LAN port is there. So what need to happen? One LAN cable they'll, need to connect on one port and another LAN cable they need to connect on another port. Why? This is for using the phone. So it will have one VLAN, for example. This is for using internet. It will be having another VLAN, for example. So what Cisco suggests, don't do this. Okay, let us give you better solution. So they are saying use a connection like this. Use a single port on the wall jack. Use a single cable connected to the switch. Sorry, this IP phone. And this IP phone is kind of a mini switch. Okay, mini switch. What happens that this is basically an access port. Okay, you'll make it access, switch port mode access, and on this you will define two VLANs. So you'll say you'll configure two VLAN. Let's say you're configuring VLAN 50 for data or internet, and you are configuring VLAN 100 for internet, right? Oh, sorry, not internet. What is that? IP phone, because
It's
for internet we have 50. Let's say this is phone traffic, okay, or voice traffic, whatever you call it. Now, this interface will carry both. So first you will say switch port mode access. Let me show you the configuration if you don't know already. So you'll say, okay, interface is 0 by 3, for example. So switch port, okay, before that, let's say I have VLAN 50 for my data traffic, and also I have VLAN 100 for my, let's say, phone traffic. Okay. Okay, name, right? Then if you'll say that do I have my VLAN? Show VLAN brief, not this one. So you have your VLANs. Now I want some interface E0 by 3, right? So I'll say switch port access VLAN 50, which is your data VLAN. Okay. And then you will say switch port voice VLAN 100. Okay. So you are running both commands in here. So if you'll check here, 50 and 100, right? So this interface is being shown in both of the VLAN. Normally, you will not find it, okay? One interface will be part of one VLAN. Yes, it can happen that multiple VLANs are part of a single interface, which is trunk. But single interface being part of multiple VLANs, it's possible only when you are using it with the voice VLAN, right? So this is from the configuration point of view. Now, how Cisco make it possible? So there is a CDP protocol working, Cisco Discovery Protocol. And if you remember CDP, it carries the information of, okay, this is your voice VLAN, this is your data VLAN, and this, what is that? Phone. It will pick which is the phone VLAN and it will send further the data VLAN. This is how it happens. So basically on one single interface, you can kind of configure the dual VLAN. So one of them should be or must be, you can say voice VLAN. It cannot happen like any other two VLAN. No, one normal VLAN and one your voice VLAN. Okay. All right. Then what do I have further? Anything in here that we also need to discuss? So I guess that's pretty much it about this output in here. Pruning and all we'll talk about later on. Okay, let's get back to study here. Okay. So I think no problem about configuring access and trunk. And if you remember, the MAC address table is made per VLAN. Okay. If you have forgotten things, if you'll check your let's say MAC table, that will be made. Show MAC address table. So in here, we don't have any, traffic going on, but when you will generate some traffic and all, you'll input interfaces into particular VLANs. So different VLANs will be having their own MAC database, right? Okay. So I guess you know about any question you want to ask me about the trunk encapsulation tagging, what is happening, how it is making the isolation of your different traffic and all. That's clear, right?
Yes, clear.
Okay. But I've written things. If there is anything, you can read it. Yes, so this is the point basically. So when the receiver is receiving, it will, let's say it is a broadcast, right? So the broadcast, okay, let's say there is this device in VLAN 10 and on switch 1, for example, this is VLAN 10 and this is 10.10.10.5 and there is this another device in, let's say, VLAN 10, maybe in the same switch or maybe multiple switches apart, right? And there is this another device in VLAN 10, then 10.10.10.6. This has MAC address of B, it has MAC address of A. And now if it want to ping 10.10.10.6, it has the source IP, destination IP, source MAC, but it doesn't have the destination MAC. So it will do ARP. Now this ARP will be forwarded. Let's say there is this device in 20, VLAN 30, VLAN 40. So the ARP frame will not be flooded here, no? Only to if there was some another device in VLAN 10, the frame would be flooded here and also to the trunk interface. The same will be done at each switch until unless it is forwarded to the device having this target IP address. Make sense? So this VLAN is doing what? Breaking your broadcast boundary. And increasing your broadcast domain so that your broadcast traffic can decrease. These are two line or two words you can say, which are crucial for the behavior of VLANs. So trunking is straightforward, but in higher end switches, if you try to configure trunks, then it will not allow you. So let me show you. If you'll try to make your switch to switch interface trunk, what will happen, right? Let me put it here. Interface E0 by 0, for example, right? If you'll say switch port mode trunk, then what it's saying that when this encapsulation is auto, so it cannot be configured to trunk mode. What does it mean? So if you'll see here, switch port mode in here, you can see that access is there, dot one q is there, okay, dynamic is there, and trunk is there. Leave these two, just focus on access, dynamic, and trunk. So it means what? You are statically making it access, okay? And it means what? You kind of want to make it trunk, but it is not allowing you. Because what I told you, that making trunk doesn't mean you are kind of disabling DTP. No. You need to tell it, okay, which protocol, which negotiation protocol you want to use, okay? So you are saying in here that switch port mode dynamic, you can see in here, either you can say auto or desirable, right? In that way you are defining that DTP should be initiating the connection or DTP should not be initiating the connection, right? Auto means it will not initiate, wait for the other switch to initiate the connection, and a desirable means this switch itself will initiate the connection. But it is not about that. What I'm saying, switch port mode trunk, right? But which encapsulation you want to use for the trunking? Switch port encapsulation. So which one I should use? Let's say ISL, you can see, or the dot one q, which is the preferred one, as we have discussed, the dot one q. Okay. Now you can see enter. Now if you'll see switch port mode trunk, it is not giving you any error, right? And if you'll see on one side, do show interface 0 by 0 switch port, and on other side also, right? If you'll check show interface E0 by 0 switch port here also. So in here, if you'll check that your administrative mode is trunk, okay? But other side we have not changed, so that is dynamic auto. But see here, interestingly, it was access earlier, okay? But now it has changed to trunk. Why is that? Because the other switch has initiated the trunk process. Because in here, the operational, this admin mode is also trunk. So as a result, this link has also become the trunk link. Okay. And see about the trunking encapsulation you are using dot one q. But here what is happening? It is negotiating. Okay. Other side, you have not specified ISL or dot one q. No, it is saying that I have negotiated the trunking protocol as dot one q. Right. And other things are like not relating to what we are discussing right now. So let's leave them for now. And now if you'll check, do show interface trunk, because see, if you'll check your VLAN database, the trunk information will not be found there. Why? Because it only store the information of VLANs, which are basically the access VLANs, not the trunk ones. Or if I'm saying that right, I guess you understand what I'm saying, right? So the trunk interfaces or interfaces which are part of multiple VLANs, where they'll be shown, do show interface trunk, right? And see here, the mode is on this side where I have said switchboard mode trunk. On means manually you have said switchboard mode trunk, not depending on auto, not depending on desirable. On other side, if you'll see though, show interface trunk, this mode is auto. So it shows you here the admin mode, if you remember this administrative mode, which is written in here, right? Then if you'll see encapsulation, it is N here because switch 2 has negotiated as per switch 1. But in switch 1, you will not see N. It is only dot 1Q, which you have configured. Status here is trunking. Here is also trunking. Native VLAN by default is VLAN 1. And you can change it though, but by default it is VLAN 1. All the VLANs are allowed, but by default only one VLAN is active. See here, in here I have 150 and 100 because on this switch I have those VLANs, right? Okay, let's check again. If you remember, I have configured these VLAN earlier, right? 50 and 100. So that's why you can see they are in the active management domain. But on switch 2, I just have one VLAN. Okay, just VLAN 1. So that's why it is there. Pruning and all I'll discuss later on. But any questions so far? Just one example, one case I have shown. Okay. Then what else? Let's see here. Okay. See, in multiple switches, in many other different switches, maybe your trunk will not form like this. Okay. What will happen? You will need to run this command, just switch port. If by doing everything, the trunk doesn't come up, just run this command. Okay. Because what the switches thinks sometimes the layer 3 switches that we are no switch port, right? So you need to, kind of enable the behavior of this L2 by using this command of switch port. Okay, so this is about the configuration of trunk by using DTP. And you can also check, okay, if other side, if you try to do something like this, that interface is 0 by 0, switch port, and you say trunk encapsulation ISL, right? And switch port mode trunk switch port. Do show interface trunk. See, can you see the messages in here? STP messages, received BPDU, okay, block port type, inconsistent port type. So if you'll check, do show spanning tree protocol, do show span, right? Do show span. Can you see this? Have you ever seen this in STP? How many states are there in STP? If you remember. Yes, STP states.
Listening, learning, and forwarding.
Forwarding. So the R's are for RSTP. Yes, right. So if you'll talk about, all the states, so those are, disabled, blocking, listening, learning, forwarding. So typical, that basic variant of STP, CST. So it is kind of your sixth STP state, the broken state, type inconsistent state. So this is one of the reason it can be there when you are troubleshooting, that maybe different sides, your different interface modes are there or different trunking encapsulations are there. So either side you need to change it. So I'll say, okay, switch port trunk encapsulation is dot 1Q. Now it should, in the next BPDUs, it should, revert to the normal configurations, right? It is now. Why is this happening? Let me open it again. Makes sense, right? So this is about your trunk part. Is there any other combination I need to talk about? Let's see in the notes. So this is all about, I think. Okay, see now let's talk some of the things which may be new for you. That if you'll check here, that so we no longer talk about ISL, okay? So forget ISL. We talk about mainly on about the dot 1Q. If you'll see, you have a frame, and in that frame you'll add that 4 byte of dot 1Q, 80.1Q by basically, which fields are there. So 4 byte means what? Your 32 bit, right?
Yes.
You see here, this is 2 byte field. and this is a 2 byte field total in total. So 2 and 2, 4, right? Out of this 2 byte, you can see this is simply defining that it is your dot one queue. Okay. So this 2 byte defining the type of protocol you are using. Okay. What about this remaining 2 byte? In here, there are separately defined three fields. This we are, kind of familiar with that. This is our VLAN ID tag. So we all know what is the size of VLAN ID? 12-bit, right? That's why we have this 4096 total number of VLANs ranging from 0 to 4095, out of which this and this is not usable. So the usable range is 94, this one, okay? And out of this, we know that 121001 are normal VLANs. 10022345 are the legacy VLANs, and next up to 4094 are your extended VLANs, right? Special purpose VLANs. So in typical enterprises campus area networks, you will find these normal VLANs in use, right? But okay, what are these two fields for? So mainly this is used, but this is for your, prioritization of traffic, for example. When you are using that quality of service at layer 2, so you are defining the class of service for different traffic types, and then you are defining the drop identifiers for your, if you have studied QoS in your CCNP studies, maybe you have the idea about that. But I have mentioned some things. Let me show you. So this is all about this field of the tag, 4 byte tag of your port 1Q. Okay, so this represented is your 802.1Q, and these are all. And see, 3 bits field is there priority. So 3 means what? 2 raised to power 3 means 8, total 8 combinations, 0 to 7. So the 8 traffic classes you can define. If you remember your routing protocol, the L3 control plane, the DTP, STP, CDP, VTP, all L2 control plane traffic, they have the highest priority. So you should know that control plane has higher priority than your data plane. Then all different traffic classes that you can define. So it's all about that. Okay. So as we have, okay, this is interesting that as we have admin mode and operational mode in your interface type or the port types. So in here also in the encapsulation models or the protocols, we have these two mode. Okay. So if you'll configure, let's say, negotiate on one side, and you are saying dot one queue on one side, as I have shown you, okay? The admin side on one side, I said, okay, dot one queue. Other side, it was negotiate. So what was the operational mode on other side also? Dot one queue,
Not thank you.
right? So it happens the same in here also. It negotiate in this order, and it is kind of not good, but because ISL is Cisco proprietary, they give priority to ISL,
Mm.
right? So access port comes at last when you are not configuring any kind of trunk. All right, DTP, then it is not DTP, and these are DTP basically. Okay, how to disable? Okay, do we have anything else that we need to talk about in between? So this is layer 2 multicast, the DTP timers, and also if you'll check here, if I show you, let me capture this. Okay. So if you'll check here, it's your DTP. Okay. Check any of the packet of DTP and where it has gone. Let me say. So STPs are there after every 2 seconds. So you'll find them pretty frequent. And then if you'll check, we have somewhere it was DTP. Okay. It is at time of 8. And if you'll check the next DTP, if I can see it. Okay. Then it is 39. So basically around 30 seconds it is sending the next one. Okay. Again, if you'll check your DTP, if I have not missed any, then you can see maybe in between there was one also 39 to 84. Okay. Maybe I missed that. But if you'll check in here, what is the timer of your DTP packets? 30 seconds. So after 30 seconds, this DTP packet will be exchanged. And what is the data in here? If you'll, kind of pay attention to that. DTP. Okay. Let me search it for DTP only. So you can see that if you'll open that, so this is your, okay, first of all, this is IEEE, that frame structure we have discussed, destination address. Yeah, so this is your multicast address. See in the what is that? LSB or MSB? This side, left side, this MSB, I guess, right? 0, 1. So 1 will be 1, 1, 1 or 0, 0, 0, 1. So your last bit is going to be 1. So which indicates this is your multicast address. Okay. Source is the interface of this one in here. If you'll check E0 by 0, that is this MAC address and length and see this padding here. I told you what is the minimum size of frame 46. So this 12 byte you are adding in here to make it complete. Then if you'll check that we have two parts of layer 2 header, MAC and your LLC. So this is MAC detail and this is LLC. So you can see this DSAP, SAP. So what it is showing you, this DSAP and SAP, your DTP. Okay. and and you can see this is same, this is same. So that's what we have discussed, that you'll find it will be same. DSAP and SAP will be same. Control field as discussed, it's not used. 0, 0, 0 you'll find, because what field was let's say designed to do it, this responsibility has been given to the transport layer, the TCP, for the connection oriented sessions and all. So this is Cisco proprietary, you can see here. And this is your protocol ID in here, you can see. Then this is your DTP version 1. Then you can check about here. We are not using any CDP, sorry, VTP and all. So for that, we are missing that information. Then about, trunking, you can check. The trunk administration status is on, means this is the trunk. What kind of, so all this information you can find in your, DTP packet. So who is the sender? Again, this one. Any doubt so far? Okay. What else do we have? There are two modes, auto and auto. If there are both sides, they'll not form trunk. No initiation. So auto like to be in access mode and desirable like to be in trunk mode. So that's how it goes. So I have included all this for your reference. So we are talking about switchport modes. Any question on that? Okay, so this is important. Pay attention. So trunk will be in these situations. But in other conditions, either it will be excess or it will be your what? What was that? Down or inconsistent if there is some misconfiguration. Okay. Let me show you one thing. Let me add a device here. And if see that is shown in here. What I'll do, I'll add one interface on switch 1, that let's say interface is 0 by 1, switch port access. So we have VLAN 50, right? If you will check do show VLAN brief, we have VLAN 50, right? So switch port access VLAN 50. Okay. And if you'll check again, do show VLAN brief, this Ethernet 0 by 1, okay, is in VLAN 50. Okay. Now let's check this capture of 0 by 1. Okay, let's sometimes pass. Can you see that? DTP. So is this is kind of access. If you'll check here, do show interface is 0 by 1 switch port. Okay, switch. If I can write that. So what is this? Static access, right? The operational mode. But what about admin mode? That is dynamic auto. It means you are not saying, if you'll check in here, do show run interface is 0 by 1, that this is your access port. No, you're not saying that. So it is not disabling DTP traffic on that interface. Make sense? So how to disable DTP? For this kind of interface, you will say switch port mode access. Now you are saying that this is your access port. Need not send DTP packets here because it doesn't make any sense. There is not going to be any trunk link in here. Now, if you'll check in here, you will not find any DTP traffic going on, only STP. Okay. What about in here? Let's say one side do show interface is 0 by 0 switch port. Admin mode was trunk. Okay. And on this side, I think I haven't said manually trunk. What I'll do, interface is 0 by 0 switch port mode trunk. Right. So both sides I have done what? That it is trunk. So I'll say 0 by 0. So I am filtering DTP only. Okay, let me clear that. So can you see? I think this was the old one. Let's wait for new one. So new one is also there. So still you can see. Okay, this is very previous one. Okay, let me come to the latest one. Earlier it was here 9.4. So 25, 26 around it should be there. Not showing me, or was it there? Okay, let me say DTP. Okay, only. So you are saying that 57 also it has sent some DTP packet. So I don't know why it is not showing me at exact interval, but still you can see the traffic going on. Still the traffic is going on. So how to disable this? Again, that I have manually configured the trunk, then why should I be relying on DTP and all? So what you can say that no switch port, no negotiate. Okay, like this. Similarly here, that no switch port, no negotiate. Now it will disable your DTP traffic. Now if you check your links, you should not be getting any DTP packet after this. Okay, make sense? So this is why and how you can, why you should disable DTP and how you can disable DTP. It is confusing for, many people, remember. Okay, what about the router and the encapsulation or tagging? You know about that inter-VLAN routing, right?
Yes.
So what we do that, let me just quick introduction about that. Let's say we have a router in here and we have a switch in here. Let's say we have some devices in different VLANs, for example, this is in VLAN 10, this is in VLAN 20. So for intercommunication from VLAN 10 to 20 devices, we have two solutions. Either, you can use dedicated links like this. Put this in here in VLAN 10, put this in here VLAN 20. Let's say for 10.10.10.0 network you are using for VLAN 10, 10.10.20.0/24 you are using for VLAN 20. On this interface, you'll say the IP will be of this network, okay? And on this interface, IP will be of this network, and this will be gateway for this VLAN, this will be gateway for this VLAN. Great. But the problem is again same that you will be wasting your links. So what we can do then? That have just a single link, configure this as trunk on switch, and here make different sub interfaces and have high speed link, by the way, because it is getting going to get all the traffic. So for, let's say, VLAN 10 to 20, the traffic is going to be like this and coming like this, request, and reply also is, kind of coming like this. So it is going to take all the burden of the traffic. So have this high speed link. But yes, gig 0 by 0, you'll say no shut, and gig 0 by 0.1 or 10, for example. It can be any number, any as per the VLAN or just random number. And on this one, you'll say encapsulation, okay? .1q. So here the point is routers doesn't support DTP. That's what I'm trying to say. So there you can define ISL, you can define .1q, but you need to define that manually. All right. And then you'll put it into the VLAN first interface or the sub interface. Then second sub interface you'll put into, let's say, encapsulation .1q 20. And then your traffic will be, passing through and communicating through. Is that clear about the routers?
I
Well,
have one question.
yeah,
It's in real time scenarios, like we do the router on a stick lab. But I have one question, like, what if can we take two ports from the router and make them and uh, non-routable ports, then making them into layer 2 trunk, then making them a layer 3 ether channel. Can you do that like?
we'll see that. Totally doable. If you want, there are different ways of doing things. Whatever you want in your way or whatever your, environment want in that way. So you can
Yeah.
configure. We'll talk about layer 3 ether channel. There I'll talk about the exact scenario.
Okay.
Okay. Right. Then what else? Negotiation we have talked about. Why to disable DTP? Yes. Troubleshooting trunk links. So this is important, as I have briefly talked about that your parameters of trunk link, they must match. Okay. If you change something, then the trunking will break. Okay. What should be same? Your native VLAN, your allowed VLANs, and if you are using VTP, which we'll discuss tomorrow, the domain name and the VLAN it is passing. So basically, let's say one side you are using .1q, other side also it should be. So the parameter must be matching in a single line, if I can say. So coming to allowed VLANs or a trunk interface, so there are two type of pruning. If you remember the word pruning, if you have heard about that earlier. So what is pruning means? You are kind of disabling something, right? So let's say,
Yes.
right, you have a switched environment And there are, let's say, in this switch, you are making, in total, there are 10, 20, 30, 40, and 50. Let's assume I have these five VLANs on every switch, okay? But let's say
Okay.
between switch 1 and switch 2, all right? We have, let's say this is in VLAN 10 and 20, okay? This is VLAN 10, 20, and 30. Now you tell me on this trunk link, do I need VLAN 40 and 50?
No, you don't
No,
need.
right? So it is
No.
kind of, if you are enabling them on this trunk, it is kind of making the traffic generating unnecessarily on this trunk link. So what you can say, okay, either you can disable or prune them manually, right? Which is not a great solution in bigger networks, by the way, not scalable. So that's why we use the, what you can say, dynamic or auto, what is that, pruning. So that is possible in VTP, we'll talk about. But here in trunking normally also, I can say, okay, on this, let's say this is your gig 0 by 1, I'll say switch port trunk allowed VLAN. In here, you can say remove 40 and remove 50. So only your 10, 20, and 30 will be in the active VLAN forwarding domain, right?
Yeah, allowed VLAN remove command. We have to add the remove term.
We'll talk
Then
about
we
that.
will add this.
Let me show you.
Can
If
you
you
show
go
this?
here
Okay.
and let's say, let me configure some VLANs in here. VLAN 10 to 15, for example, okay? And in
Okay.
here also, VLAN 10 to um, 15, right? Then if you check do show interface trunk,
Yeah.
let me just get out of here so that it can update my VLAN database. Now, if you check show interfaces trunk, can you see that these VLANs are allowed and passing through? Okay, and
Yeah.
not prone. They are not prone. In here also, you can check that show VLAN brief. Always verify your configurations before doing the testing. Okay, always make it a habit. Show interface trunk. I forget most of the time and I waste so much time. Remember. Okay, so here also I have 1500. So that's what. Okay, let's talk about 50 and 100 only for now because 10, 15 I need here, 10 to 15 I need here. Let's say I don't need 50 and 100 on this trunk link. Okay, so how to remove
Okay.
them? If you will see interface, the trunk and switch port trunk, the command will be, if you'll check here, allowed. If you want to remove, still you need to start with allow. That is, interesting. Then VLAN, then comes the keywords, which will define which operation you want to perform. Okay. Now, if let's say you are saying 50 only and you press enter, what will happen?
That will only allow this VLAN 50 on this trunk.
50 only. So this is very disastrous. So we
It's
need to be very careful about this. It will only allow VLAN 50, right? But I'll say no, then it will resume by a normal operation. Okay, then if you'll see that if you need to add a particular VLAN, for example, let's say, first let's remove it first. What I'll say, remove for
yeah.
removing a VLAN. Now, if you'll check here, only your VLAN 50 is gone. But if you want to add that VLAN, just a single VLAN, then what you need to say? Not write 50, but add. So when you want to add one by one, write add. When you want to remove one by one, write remove. So
Yeah.
that's what basically it means. What else is there?
All is the manual process for the pruning, right?
Yes, that's why it is
Yeah,
manual, right? So you can do all the operations in here, except means you'll say only this one will not be, removed. All other will be, okay. This one will not be allowed. All others will be allowed. I guess. Let me check. Yes. Okay. So this is manual pruning basically. Clear? And this is interesting. When we will talk about VTP. So you can see the VLAN setting in here that VLAN is shut down or suspended or what. Right now we are using the VLAN. They are up and working and all. But if you'll say, okay, I'll go VLAN 50, okay? And in here, can you see this command shutdown? Okay. So if you'll say shutdown, this VLAN will be shut down only for this switch. Let's say you are using VTP and VTP was transferring this VLAN to other switches also. So this VLAN will be on or no shut on other switches. But if you want a particular VLAN to be shut on every switch, then you will say that it should be suspended. What is that command? Um, State suspend, right? So for that, I need to write state suspend. Okay. So in this way, this particular VLAN will be, let's say, shut down for all the switches. Clear? Any questions so far? Native VLAN, just for completion, let me tell you how you can change. Okay, we should be in the trunk interface. If you'll check do show interface trunk right now, your native VLAN is 1. But if you want to change it, you can change it. Switchport trunk native VLAN. Let's say you want to make VLAN 10 as your native VLAN. But the thing is, as I told, parameters must match on both sides. If one side is 10, other side is 1, then it is problematic, right? So again, you can see PVID inconsistent. Earlier it was another thing, state inconsistent or something like that, right? In here it is saying uh, per VLAN identifier inconsistent. It means your native VLAN is mismatching. I'll talk more about it in the STP section when we'll talk about the interoperability of different STP flavors. But yes, so you need to either change on both side or keep it default. Now the order should restore to the normal. So after some time, after that after next BPD use, it should be okay. See, so this is about the net. Any question on native VLAN? These are all the things that I have already talked about, that why and where native VLAN. This I'll talk about in again, as I told you, on trunk links, there are different type of BPDOs exchanged. So this in upcoming sections.